Morning, everyone. Is my voice clear? Am I audible? Just confirm once. After that, we will start. Morning, everyone. Okay, I think its voice is clear. So let's start our session. Today, we are going to study about EM waves, electromagnetic waves. Okay. Basically, what you have seen, or in the previous chapter, I have told you that a charge in stationary position creates electric field around itself. When that charge starts moving with constant velocity, it is creating some form of magnetic field. But when this charge is accelerating or oscillating, then it creates electromagnetic waves. These waves are very common in our discussion in daily life. Like you can say the mobile communication that we are having, the Wi-Fi communication, whatever the wireless communication is almost done by these EM waves. You can say X-ray is a part of electromagnetic. The visible light that you can see, the sunlight that is coming to our Earth is also an electromagnetic wave. So let's start our discussion. First thing that we'll study in this chapter is you can see displacement current, then Maxwell Ampere's law, then electromagnetic waves. A lot of topics are there to be studied. So first, start. What is displacement current? You can see here. Okay. Let me tell you the displacement current is generally the current which is created by the change in electric flux, which is generally created by the change in electric flux. Is this point clear? Whenever there is a change in electric flux, there will be a form of current which is known as displacement current. For example, you can see here, like these are the two capacitor plates which are connected by some voltage source. Like this. Either you can add AC or DC. Let's suppose I am adding AC source here. Some AC sources connected here. These are the plates of the capacitor. So between these plates, there will be a potential difference between the plates of the capacitor, and there will be an electric field. This electric field, because the alternating voltage is applied, so this field will also fluctuate. This field will also have variable values. If this field is variable, then the flux linked with any cross section area in this portion, flux is also changing. So there will be a current in this portion, and that current is called as displacement current. That current is called as displacement current, and its value is epsilon naught d phi over dt, where d phi over dt is what rate of change of electric flux. Yeah, okay. What I'm saying, remember it. D phi over dt is what rate of change of electric flux. You can add E here so that you can identify that they are talking about electric flux. Clear? Okay. One more thing, displacement current is normally a current. Its unit is also ampere. So you can say unit is also ampere. Another thing that I will tell you is that it follows the continuity. It follows the continuity. Like if you can see here, these are the wires. In the wires, there is conduction current. There is a current due to the conduction of electrons, due to the conduction of free electrons. So there is a conduction current. Between the plates of the capacitor, there are no wires. So the current in this portion is known as displacement current. Current in this portion is known as displacement current. Is it clear? Okay. Now, now we know the formula for displacement current. We know that it follows continuity. It follows continuity. Okay. That means in this system, IC will be equals to ID. Continuity means IC will be equals to ID. ID means displacement current, IC means conduction current. These two will be equal. Okay. Moving further. Now, what Maxwell's Ampere's law? What did he say? I think you know that Ampere's law. I think everybody knows that integral B dot dl is equals to mu naught times the current enclosed by the loop. This was the Ampere's law that we have discussed already in the previous classes. Now, Maxwell suggested that for the Ampere's law to be consistent in every situation, we must add a term which is nothing but the displacement current, which is nothing but the displacement current. So he corrected it, or you can say he added the displacement current in it. Mu naught was already there, I was already there. He added the displacement current in it, and this is the Maxwell's Ampere's law. So just remember the equation. This is Maxwell's Ampere's law. Moving further. Now there is electromagnetic waves. On your screen, there is some kind of, you can see image is running, or GIF, it's a kind of GIF. What you can see here, that waves are, in which direction waves are moving according to you? The waves are traveling, and these waves are traveling in the direction of positive x-axis. You can see that this is x-axis, this is y-axis, this is z-axis. Clear? Now, waves are traveling towards x direction. Red color line is representing magnetic field, and blue colors is representing electric field. Now you can clearly see that electric field is oscillating in the y direction. Magnetic field is oscillating in the z direction. And waves are traveling in the x direction. So EM waves are what? They are formed by oscillating charge. They are formed by oscillating charge. That is the first point. Oscillating, or you can say accelerating charge. Generally, oscillating charge is used to create the EM waves. Now, the next point is, in the EM waves, electric field and magnetic field both vary sinusoidally, perpendicular to each other and perpendicular to the wave propagation. What is my point? In electromagnetic waves, electric field and magnetic field both vary. Vary means change करते हैं. Both vary perpendicular to each other and perpendicular to the wave propagation. So these are the transverse waves. These are the transverse waves. Okay. Now, after seeing this animated graph, magnetic field is in Z direction, electric field is in Y direction, and they are propagating in X direction. I think this point is clear. Now, there are some punchlines that you should remember. First is they are produced by accelerating charge, or you can say oscillating charge. They travel with the speed of light. They travel with the speed of light. In vacuum, if I say in vacuum, the speed of EM waves is nothing but 1 over root of mu naught epsilon naught, where mu naught is what? Do you know what is mu naught, Chichuni? And what is epsilon naught? Mu naught is what? Permeability. And epsilon is what? Permittivity. Permittivity. Now, if I say again, if they are traveling in some other medium, like in water, if they are traveling in water, like they are traveling in some other medium, then what will be the velocity? The velocity of the speed of light or the speed of EM waves is nothing but 1 over, okay, there is a correction. Uh, hmm, this is C over velocity of EM waves or speed of EM waves in any other medium is C over root of mu r epsilon r, where mu r is the relative permeability, epsilon r is the relative permittivity. That is relative permeability. And this is relative permittivity. Permittivity is related with the electric field. Permeability is related with the magnetic field. Both are the same things, but the difference is that electric field, the permittivity is related to the electric field and permeability is related to the magnetic field. The amount of magnetic field that can pass through the medium is called permeability, and the amount of electric field that can pass through a medium is called permittivity. So these are the same things, but the difference is in the field they are dealing with. They are dealing with electric and magnetic field respectively. Clear? This formula should be remembered. I am again telling you, you should remember this relation. Both of these relations you should remember. What is the difference in them? This is in vacuum, if I am right with the spelling, and this is in any medium. Any medium other than vacuum. Okay. Now, another point, they are transverse in nature. Transverse in nature, I have already told you that electric field, magnetic field, and wave propagation, these three things are mutually perpendicular. These three things are mutually perpendicular. That means if I say that light is traveling or the wave is traveling in y direction, then in which direction electric field and magnetic field will be? You can say electric field and magnetic field will be in the x and z direction. Is it clear? If wave is propagating in y direction, then they will be in the x and z direction. Clear? Now, the third and most important point is the cross product of vector E and B. Remember the word E is written first. E cross B gives the direction of wave propagation. E cross B gives the direction of wave propagation. Clear? For example, if I am saying that electric field is in I cap, magnetic field is in K cap, then in which direction wave will be traveling? In which direction wave will be traveling? Gauri, Veena, Chichuni, anyone? Okay, I'm repeating the question. E, that means electric field is in the I cap direction. Magnetic field is in the K cap direction. Then what will be the direction of speed? What will be the direction of, you can say, wave propagation? Veena is saying minus K. Okay. Gauri is saying J cap. Okay. Minus J. Veena is saying minus J. Okay. Minus J. Okay. Now listen very good. The product E cross B will give the direction of wave propagation. E cross B, if I say, that will be I cross K. And I cross K, I think everybody remember this relation. I, J, and K. So I cross K will be J cap, but it is negative J cap. Why negative? Because we are moving opposite to the circle. So that will be minus J cap. Very good. Everybody, I think, answered correctly. That is minus J cap. So the remember this relation. This is very useful. Now moving further. Another point. Electromagnetic waves carry energy. They carry energy with them. For example, whenever the light is coming, you can examine with that. Whenever sunlight is coming, sunlight is also an electromagnetic wave. Whenever the light is coming, it carries some energy. And this energy is shared equally between electric field and magnetic field vectors. This energy is shared equally between electric field and magnetic field vectors. So how much energy is this? Energy or average energy in the electric form is half epsilon naught E RMS square. Remember the word half epsilon naught E RMS square. E RMS is the RMS value of electric field. And you know that what is ERMS? ERMS is E naught by root 2. I think you know that ERMS is RMS value. Everybody knows that is E naught by root 2. If you place this value in this relation, then you will get 1 by 4 epsilon naught E square. 1 by 4 epsilon naught E naught square. What is E naught? Peak value of electric field. Peak value of electric field. Remember the relation. What is the electric energy density? What is the electric energy? What is the amount of electric energy density the waves are carrying? That is 1 by 4 epsilon naught E naught square. If it is given in terms of RMS field, then you can use this relation. Both the relations are useful. Now, what is the amount of magnetic energy density? Magnetic energy density is similar, nothing but 1 by 2 B RMS square by mu naught. And if you place the value of BRMS, it will become 1 by 4 mu naught and B naught square. B naught is again peak value of magnetic field. Write down the formula on your notebook right now, because these are important relations. Peak value of magnetic mu naught is, again, you know that permeability of vacuum, permeability. This is RMS value of field. It will be used. Now, one more thing that you should remember. Whenever the electromagnetic wave is traveling, the ratio of electric field and magnetic field is a constant. I am repeating my word. Whenever the electromagnetic wave is traveling, the ratio of electric field and magnetic field is a constant, and it is given by C. That is the speed of light. C is what? Speed of light. Remember this relation, or this relation is valid for any instant. These are the peak values, or it can also be written as E over B is equals to C. That means at any instant, the ratio of electric field and magnetic field is speed of light is equals to the speed of light. Remember this relation. This is very important relation. Okay, moving further. What is the intensity of electromagnetic wave? If I say intensity, intensity means energy coming per unit area, energy coming per unit area per unit time is called intensity. Again, energy per unit area per unit time is called intensity. Now, if you write the unit of this intensity, energy per unit time, that is joule per second, that is watt per meter square. So what is the unit of intensity? Is watt per meter square. Clear? This is the unit. What is the meaning of intensity? The amount of energy coming. For example, listen again. This is a surface. On this surface, some EM waves are striking. Some EM waves, some electromagnetic waves are striking. So, what is the amount of intensity with which they are coming? The intensity is energy coming to this surface per unit area, per unit time, given that this surface is perpendicular to the radiation. Surface is perpendicular to the radiation. Very good. Most of the times they will ask you the energy reaching the surface in some time. So energy can be written as IAT. You can transfer things here. Na? Okay. Now moving further. If some energy is coming, then there is a possibility that some momentum is also transferred. Some momentum is also transferred by the waves, by the EM waves. So the momentum that is being transferred by the EM waves for a surface, for example, this is a surface. This is again important question that I am telling you right now. This is a surface. Surface may be of two types. One is absorbing surface. Another is reflecting surface. You can see here. Both surfaces are represented here. Whenever the EM waves are coming and strikes perpendicular to the surface, mark my word, strikes perpendicular to the surface, these relations are valid for this perpendicular or normal incidence. So whenever these rays are incident, these waves are incident perpendicular to the surface, then the amount of momentum that is being transferred to the surface is E over C, where E is the energy and C is the speed of light. This is for what? This is for absorbing surface. The surface which absorbs the radiation and does not reflect anything, completely absorbs everything. Now, if the surface is reflecting, then this momentum is 2E over C. Momentum is 2E over C, where E is again the energy, C is again the speed of light. And you know that E in the previous slide we have calculated as E is equals to IAP. E is equals to IA. You can place this value IAT over C. Clear? P is what? Momentum. Moving further. Now there comes the last topic of this class. After that, we will go with questions. Electromagnetic spectrum. Now this is mentioned, but the thing is, you need to remember this. You need to remember, you need to uh, read this out from your notebook, from the NCRT book as well. Because the uses of these spectrum is very important. What are the uses of X-rays? What are the uses of ultraviolet rays? What are infrared rays? What are their uses? So in this diagram, I have shown you that there is gamma ray, X-ray, UV, infrared, and this is microwave. In fact, radar means microwave. And after that, these all are categorized in the same portion that is known as radio waves. These are known as radio waves. The last four columns are just radio waves. So radio, micro, infra, visible, ultraviolet, X-ray, and gamma ray. This is the pattern. Clear? Out of which they will ask you, they will give you 3, 4 options, and they will ask you if the order of their wavelength, which is highest wavelength, which is lowest wavelength. So these things can be radio waves has the highest wavelength, gamma rays has the lowest wavelength. If gamma rays has the lowest wavelength, then their frequency will be maximum. I think this point is, now, these as highest frequency. Frequency means F. Out of visible region, this is the visible region, and out of visible region, you can say it varies from 400 nanometer to 700 nanometer. 400 to 700 nanometer. Now, if they are, it is varying from 400 to 700. The highest wavelength color is of red color. You can see this. Highest color 700 is of red color, and the lowest is of 400, which is of almost violet color. You can remember this relation as well. Now, what is your task? Your task is to read out the applications, read out the uses of these portions. What are the uses of microwaves? It is already mentioned radar system it is used. What are the uses of infrared? What are the uses of UV? What are the drawbacks? What are the problems with the UV radiation? Everything you should remember. Now, moving further. Now, we will take some questions. Now, be serious. Small chapter, questions, all questions are important. First question. Okay, let's start with some easy questions. Let's start with some easy questions that you can answer. Very okay. Okay, answer this one. Answer this one. I will give you 30 seconds for this. You should remember the relation. You should remember the formula for that, as I think. There is a transparent medium which has relative permeability and permittivity given as 1 and 1.44. The velocity of light in this medium would be. So, what is the velocity of light? Light is an electromagnetic wave. So, velocity of light in any medium, I have told you it is c divided by root of mu r into epsilon r. I think you remember. Now just place the values. C is what? 3 into 10 raised to the power 8 divided by root of mu r is given as 1.44 into 1. Veena is saying option A. Okay, let's check it. This 1.44, if I take, it will be 1.2 now. That is 3 into 10 raised to the power 8 divided by 1.2. 12 into 12 is 144. 2 decimal points. That is 1.2. Now, if I divide it, 2.5 into 10 raised to the power 8 meter per second. Very good. Very good. Well done. Well done, Veena and Gauri. Very good. Now take one more question. That is again going to be an easier question. Okay, tell me this one. Tell me. You again have 30 seconds. You again have 30 seconds. I will not disturb you for the next 30 seconds. Is anything coming to your mind that how to start this question? Anything? Very good. E cross B. Very good. Okay. One thing that I will tell you, remember my words. Remember, Wave is propagating in X direction. Clear? That means if you do the E cross B, it will come in the I cap direction. One thing that is very good, Chichuni. Next thing that I have told you is electric field and magnetic field both are perpendicular to each other. Both are perpendicular to each other. Do you remember this one? So if both these vectors are perpendicular to each other, then in that situation, the thing is should be, if two vectors are perpendicular, then their dot product should be what? If these two vectors are perpendicular, their dot product is should be zero. Very good, Gauri. Their dot product should be zero. That means one is representing E, another is representing B. If you do the dot product, it should come zero. And in the option in which it is coming zero is your answer. But in a situation, in a case, if it is coming zero in more than one options, then you need to apply E cross B. Then you need to apply E cross B, as you know that doing cross product is relatively difficult as compared to the dot product. So first of all, we will check with dot product. If it is coming zero in only one option, then this is our answer. If it is coming zero in more than one options, then for those two options only, I will check cross product. Clear? Now check. For option one, how to do the dot product? J is multiplied with J, K is multiplied with K only. So J, if I J multiply, it is minus 1. Minus minus plus 1, okay. And K is also plus 1, that is 2. In this case, this is again 1 plus 1, that is 2. That is, it is not coming 0. In third option, it is coming minus minus, that is plus 1. And plus minus, that is minus 1, that is 0. Option C is saying 0. Very good, Gauri. Option D is again saying that is minus 1 and minus 1, that is minus 2. That is only option C is giving us dot product to be 0. Our answer is directly C. If it was coming 0 for two options, then we will do the cross product for those two options only. I think the thing is clear. So I think one more thing you can remember, E cross B gives the direction of wave and E dot B should be 0. E dot B should be 0. I think the question is clear. Now, we will move further. Okay, tell me this question. This is easiest one. This is the easiest question. A, B, C, D. Everyone is saying B. Very good. Accelerating charge produces electromagnetic waves. Very good. Very good, Shishni, Veena, and Gauri. Now, again, one more question that we can take here. Tell me this question. You can say velocity V I cap. That means wave is moving in I cap. That means positive x-axis. The instantaneous oscillating electric field of this wave is along y-axis. That means electric field is along y-axis. Okay. Y-axis means electric field is along J cap. Okay. Then the direction of oscillating magnetic field they are asking. Gauri is saying option B. Very good. So again, the same thing is used here. Very good. Everyone is saying B. So what you should use? E cross B should come out the direction of wave, that is I cap, it should come. Very good, Veena. So E is in the J cap. What should be the direction of B so that it is I? So you know that this is J cross K is going to be I. So K cap means positive Z axis, which is option number B. Now easy questions are done. Now we are moving towards some good questions. Starting with first question on our slide. Okay. Question A capacitor of capacitance C, okay, is connected across an AC source of voltage V, given by something V naught sine omega t. The displacement current between the plates of the capacitors would be. So the simple thing is they are asking the displacement current, and we know that displacement current is epsilon naught d phi over dt. This is what we know. Now the question says voltage is given. According to the question, voltage is given. What I can write here, epsilon naught is here, d over dt is also here, and phi is what? Electric flux is what? E into A. I think it is clear. Now area of the plates is constant. Area of the plates of capacitor is constant, so I can take area outside, that is epsilon naught A d over dt and E. If I take A outside the differentiation, it will remain only E. Why E is not constant? Because E electric field vary as the potential varies. So potential is V naught sine omega t, that is variable. So electric field will also vary. Now, what I am doing, I am multiplying with D and dividing with D. What is D? D is the separation between the plates of capacitor. This is the capacitor. A is its area, D is the separation. So D is what? Separation between the plates of the capacitor. Now I think it is clear to you why I did so. Because if you can see epsilon naught A over D, can anyone tell me what is this epsilon naught A over D? Do you remember what is epsilon naught A over D? This is very famous relation. This is the capacitance. The capacitance of a parallel plate capacitor is what? A epsilon naught over D. So this is capacitance C. This is not the speed of light. This is capacitance into field into separation. The field is E, separation is D, is the potential difference between the plates. So that is d over dt into potential difference V. So the relation, or you can say golden relation, another golden relation for displacement current that you should remember is ID is equals to C dV over dt. This dV over dt. Okay, Gauri is saying option B is correct. Now let's check. So ID is equals to C is already there. D over dt. V is V naught sine omega t. Now we need to differentiate it. C is already outside. V naught is a constant. I can take it outside V naught. The differentiation of sine omega t is cos omega t. And further differentiation of omega t is what? Omega. So displacement current is what? CV naught omega cos omega t, which is very good option, which is B option is correct. Very good, Veena. Can you remember this relation, everyone? C dV over dt. This is the displacement current, and original displacement current, you know that is epsilon naught d phi over dt. Clear. Next question. Again, the question says a parallel plate capacitor, okay, of 20 microfarad. This is not milli, this is microfarad. 20 microfarad is charged by a voltage source. Is charged by a voltage source whose potential is changing at a rate of, that means dV over dt is given. Potential is changing by a rate of 3 volt per second. This is dV over dt is given. The conduction current through the connecting wire and the displacement current, they are asking the conduction current IC and the displacement current ID. And I told you that it follows displacement current follows continuity rule. That means IC is equals to ID. So we can easily calculate displacement current here. ID is equals to I told you capacitance is given, rate of change of potential is given. So the formula that I am going to use is C dV over dt. And if you place the value, C is 20 into 10 to the power. Okay, I don't think that I need to use this power. Why I am not using? Because answer is in microampere. Answer is in microampere. So I don't change the microfarad into anything. Into dV over dt is 3. That is 60 microampere. So ID is 60. And you know that ID is equals to IC. So IC is also 60 microampere, which is option number C. Very good, Gauri. Which is option number C. I think till now every question is clear. Moving further. This is again an easy question. You can solve it. Did you come yesterday for the class? Anyone? Okay. Okay. The question says, in an electromagnetic wave in free space, the root mean square value of electric field, that means ERMS is given. The peak value of magnetic field is asked. So remember one thing, the relation between E and B is going to be used. The relation between E and B is going to be used. E is electric field, B is magnetic field. So I told you E naught upon B naught is equals to C. Clear? So peak value of magnetic field they are asking. Peak value of the magnetic field B naught should be equals to E naught by C. Now, do you know the value of E naught in the question? No, we don't know. We know the RMS value. We know the RMS value, and you know that 6 root 2. Very good. Very good. Now it's reflecting that you are well prepared for the exam. So I think I don't need to write E naught is equals to ERMS into root 2. Everybody knows that. What is the actual relation? We know that ERMS is equals to E naught by root 2. So I can transfer. So E naught, I know that E naught is equals to 6 root 2. Very good. So just place the values. B naught is equals to 6 root 2 divided by C. C is what? 3 into 10 to the power 8. Clear? So this is going to be 2. That is 2 root 2 into 10 raised to the power minus 8 Tesla. Now root 2 is what? 1.41. Everybody knows 1.414. If you multiply it with the 2, that is around 2.82. And 2.82 is nothing but option number B, option number A. C is a constant. C is the speed of light. C is what? Speed of light, and its value is constant. Huh? Speed of light. Yeah, value is constant. 3 into 10 raised to power 8. C is what? The actual term is speed of light in free space. In free space. And in free space, its value is a constant. Its value is a constant. NEET stress, Balveer. Why are you feeling so stressed? NEET exam will be very easy. Don't get stressed. Don't feel nothing like that. Okay, one more question we will take here. Just do this question. Very easy question. 20 seconds you can take. These are the type of questions that are being asked in the NEET examination from the last 6-7 years. I have taken all the PYQs. So all type of questions should be clear to you. Okay. Which formula you are going to use? Light with an average flux. You can see the unit 20 watt per centimeter square. This is nothing but intensity. That means intensity is given 20 watt per centimeter square. Non-reflecting is absorbing. Very good. Non-reflecting is absorbing. I is 20 watt per centimeter square. The energy received by the surface during the time span of 1 minute. So they are asking the energy received. You know the relation I is equals to E upon A into T. So E is equals to IAT. Place the values. I is equals to, again I am saying this is 20 watt per centimeter square. Area is given 20 centimeter square. Time is given 60 seconds. 1 minute is what? 60 seconds. Centimeter square will will be cancelled. So that will be 2, 2, 4, 624 into 10 raised to power 3. Sorry. I think everybody has answered C and C. Very good, Gauri and Veena. Just do one more question. This one. Your admit cards are out now. Okay, you can ask me. This is 104. This is not 104. This is 10 raised to the power 4. 10 raised to the power 4. Remember, perfectly reflecting surface. Perfectly reflecting surface. Situation is something like that. This is perfectly reflecting surface. Light is coming at normal incidence or energy is coming, whatever it is given. The intensity is given. They are asking, not asking the energy, they are asking the force exerted on the surface. Force exerted on the surface. Whenever they are asking the average force, whenever they are asking the average force, remember one thing, you can solve it for 1 second. You can solve it for 1 second. I think for admit cards are out. Yesterday there was a news, na. I have seen some notification on my mobile that yeah, admit cards are out. I hope that admit cards are out because your exam is also on. What is the date? 6 or 7? What is the date, Balveer? 7 is the date of exam, na. Okay. Have you got your admit card now? Have you checked with online or not? Sorry. Okay. You didn't check. I hope it was okay. I'm not sure. I will not confirm that because Some clickbaits are there, na? I have seen a notification only in the night, so I am not sure about that. Okay. So light is coming. So if I say how much energy is coming, I am telling you the average force can be calculated for 1 second duration. Every second you can say. So energy is what? I, A, and T. So energy is nothing but I is given as 25 into 10 raised to the power 4. Area is given as how much? 15 centimeter square. That is 15 into 10 raised to the power minus 4. And time I am taking as 1 second. So you can say minus 4 and plus 4 will be cancelled. So energy reaching the surface is 25 into 5, that is 125, 5, that is 37. I think clear? Okay, we are taking as 1 second because they are asking the average force. We can take any value of time. 1 second is easier because we can take 2 seconds here, we can take 3 seconds here, whatever the value of time you want, we can take. But the thing is, which option is going to be easy? 1 second is going to be easy. Value will change. Okay, I will tell you why it has no impact. I will tell you. Whenever the force is asked, I will tell you why there is no impact of time. First of all, we have calculated E. Now, the momentum. Remember one thing, the momentum. Momentum that is being transferred. You know that P is equals to, for reflecting surface, it is 2E upon C, I think. You remember. This is 2E upon C. So momentum will be 2 into 375 by C is 3 into 10 raised to the power 8. Clear? Okay, Gauri is saying option number B. So let's check it again. I think you can solve it. 3, 1s are 3, 2, 5. Clear? Am I right in calculation now? That is 250 into 10 raised to the power 8. This is the momentum. Now we got the momentum. This is the transfer of momentum. That means change in momentum. Okay, Balveer, it was clickbait now. Now the thing is, force is what? Delta P over delta T. Delta P over delta T. Now, Chichani, listen. If I have taken time as 3 seconds here, if I have taken time as 3 seconds in this energy term, then while calculating the force, average force, I have to put this delta T as 3. If I have to put this delta T as 3, so this 3 and this time T both will cancel. Both will cancel. So there is no impact of time in this situation. Are you getting my point? This time 3 second and this time 3 second will be cancelled. So that's why I am using T as 1 second. It is of no significance actually. So delta P is what? 250 into 10 raised to the power 8. So you can write it as 2.5 into, I don't think this is 8, this is minus 8. 2.5 into 10 raised to power minus 6. 25 into 15 into 2 will change, right? This 2 will change. This 2 is carried out here. This 2 is carried out here in 375 as well. Clear? Now, if you solve this P, this 2 is also here. Now, this 2 is also here. Clear? Now, if you divide by this time 2, this 2 and this 2 will be cancelled. This 2 and this 2 will be cancelled. So, there, what is the meaning of this 2? What is the purpose of this 2 second? Are you getting my point? If I can write it here, okay. Okay, okay. Is it clear now? Now, what you want to ask, Chitni? You were saying now you have some doubt of, you have some question or whatever you were saying now. Okay. These YouTubers na use clickbaits to get views actually. So that's why there are a lot of clickbaits you can see. Have you shared the question, Kisne? Okay. The question is, I can see. Okay. Is it visible to everyone? I will read it out. Okay. 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 I will read it. I will read it for you. Okay. A mass of 1 kg is thrown up with a velocity 100 meter per second. Okay. Okay. So I am drawing the diagram like this. A mass of 1 kg is thrown up with a velocity 100 meter per second. That means with a velocity 100 meter per second. Clear? So it will go up, and after 5 seconds, it will be somewhere here. After 5 seconds, it explodes into two parts. One part of 500, one part of mass 400 gram comes down with velocity something 25. Okay, I will repeat it slowly. After 5 seconds, it explodes into two parts. Now remember, after 5 seconds, how much will be the velocity? It is moving with 100 meter per second initially. So after 5 seconds, is its velocity what? Can you say that its velocity will be 50 meter per second? After 5 seconds, its velocity will be 50 meter per second. Is it clear? How I can say that? You can use the relation V is equals to U minus GT. So initial velocity is 100 minus G is 10, T is 5. So final velocity is 50. So after 5 seconds, its velocity will be 50 meter per second. Is it clear? Now it is saying it explodes in two parts. Now it is exploded in two parts. One part and two part. One part of mass 400 gram comes down with velocity. This is 400 gram. Can you say that this is 0.4 kg? It is coming down with a velocity 25 meter per second. The velocity of other part they are asking. So the velocity of other part they are asking. Let's suppose this velocity is v. So by using conservation of momentum, if I say, is the question clear to everyone now? Now, if I say using conservation of momentum, what you can write? Conservation of momentum. This is initial situation and this is the final situation. So momentum initial should be equals to momentum final. Initial momentum is what? Mass is 1 kg now. 1 kg. and velocity is 50 meter per second, should be equals to one part is of 0.4, another should be 0.6 kg. Why? Because total it should be 1 kg, na? So that is 0.4 kg. And this mass is moving with the downward with 25 meter per second, that is minus 25, plus second mass is 0.6 and it is moving with velocity v. Now, if you can solve, this is 50 is equals to minus 10 is equals to 0.6 v. You can transfer this 10 here, that is 60 is equals to 0.6 v. So v is equals to what? Can you solve it? Decimal can be removed. That is 100 meter per second. So the second part should be going upward with velocity 100 meter per second. Okay. If there is any problem, you can ask me. Very good, Balveer. Chichni, are you here? Are you there in the class? Okay, I have shared once, I think. I have shared my number. If you have any doubt, you can ask me anytime. Any one of you can ask me. Anytime you can ask me any question if you have any doubt. But it is not compulsory that I will answer at the same time. I will answer, definitely I will answer, but it might take some time. So I will answer definitely. Okay. So bye everyone.